Bismillahirrahmanirrahim. Welcome to VCI YouTube channel, dear friends. In this lecture, we are going to explain the concept of elements of a simple circular curve. To know better about elements of a simple circular curve, let's draw a simple curve between two tangent lines or tangent lines. As you can see here that this is the layout of simple circular curve, and we have draw a simple circular curve between these two tangent lines. As you can see here that these are two tangent line, and this is the simple circular curve. So you can see here these are the radius of the simple circular curve, and this is the length of the simple curve. So in the curve layout, we have considered two triangles which have already highlighted as shown with two colors. In this whole curve layout, we have considered two triangles. The one is small triangle and the other is big triangles. The small triangle is denoted by black lines. So you can see here that this is the small triangle, and the big triangle is denoted by blue lines. As you can see here that this is the big triangles. Now we are going to find the chord length. As you can see here that from this point to this point, this is equal to chord length. First we have taken a small triangle from curve layout, which is T1EO triangle as shown below. So you can see here the whole hidden line shows the whole curve layout, but from this whole curve layout we have taken this small triangle, which is considered and highlighted by black color. As you can see here that this is the triangle which is a small triangle. This is the perpendicular of this triangle, which is equal to T1E, and this is the base of the triangle, which is denoted by EO, and this is the hypotenuse of the triangle, which is denoted by OT1, and this represents the radius of the curve. So this is the perpendicular, and this is the base, this is the hypotenuse. Now from geometry, sin theta is equal to perpendicular divided by hypotenuse, and cos theta is equal to base divided by hypotenuse. So from according to this triangles, here P is equal to T1E, H is equal to radius, B is equal to OE, and theta is equal to theta divided by 2. The perpendicular of this triangle is equal to T1E, and hypotenuse is equal to radius, base is equal to OE, and theta is equal to theta divided by 2. So because the whole degree is equal to theta, and we divide this degree into two parts, so therefore theta is equal to theta divided by 2, as we have written here that theta is equal to theta divided by 2. So I have told you that we are going to find the total chord length, as we have considered that this triangle. Now we have taken we have to take first sin theta, which is equal to sin theta is equal to perpendicular divided by hypotenuse. So we can write this sin theta is equal to perpendicular divided by hypotenuse. Put the value of these terms just like ph and theta. Then sin theta p is equal to p by hypotenuse can be write sin theta divided by 2 is equal to T1E divided by r. We are going to find T1E, which here T1E, which is the half of the total chord length. So T1E is equal to r multiplied by sin theta divided by 2. As we have to find T1E to 2 times, it's mean that T1E multiplied by 2, then it will be equal to total chord length. Now again we can write here T1E is equal to r sin theta, because we got this T1E from this relation, which is the perpendicular of the triangle. So this distance, and now the total chord length is equal to 2 times of this, because this is the half of the total chord length. The total chord length is equal to 2 into T1E. Put the value of T1E, which is equal to r sin theta. Now total chord length is equal to 2r sin theta divided by 2, which is equal to this. So you can see here T1E T2, which is the total chord length. So to find total chord length, we should use this formula. And this was the concept of this formula. Now we are going to find the worst sine distance, which is equal to EF. From figure 1.2, cos theta is equal to base divided by hypotenuse. So you can see here that this is figure 1.2, and we have taken this cos theta is equal to base divided by hypotenuse. Here base is equal to OE, which is denoted by OE, the base of the triangle, and theta is equal to theta divided by 2, as we have explained before. And hypotenuse is equal to the radius of the curve. So according to figure, we can write this cos theta is equal to b by h is equal to cos theta divided by 2 is equal to OE divided by r. So we are going to find OE, as you can see here that this is the base, and we are going to find this OE distance, and this cos theta is equal to b by h calculation. So OE is equal to r multiplied by cos theta divided by 2. So OE is equal to r cos theta divided by 2. The worst sine of curve is equal to EF. So you can see here that the worst sine of this curve is equal to EF distance from point E to F. This distance is called worst sine distance. So EF is equal to OF minus OE. It's mean that from this point O to point F, which is equal to radius of the curve, from this radius of curve minus OE distance, which is equal to OE. So this OE is equal to the base of the triangle, and this OE we have find this from geometry, as we have written here that OF is equal to radius of the curve minus OE is equal to r cos theta divided by 2. This is the base of the triangle. So EF, or worst sine distance, is equal to r minus r cos theta divided by 2. So we can see that r is common, so we have to take r is common. By taking r common, then we can write this equation as EF is equal to r into 1 minus cos theta divided by 2 is equal to worst sine distance. So this formula is for finding or calculating worst sine distance. So this was the concept of this formula, as we have told you that from this figure. I hope that you will clear your concept. The other is apex distance, which is equal to BF. So here B point represent the intersection point. BF is equal to OB minus OF, where OF is equal to radius of the curve, and OB is equal to r secant theta divided by 2 according to geometry. So we can see here that this is the intersection point B, and this is the F, this is the O. So OF is equal to radius of the curve, and OB is equal to r secant theta divided by 2, which is the opposite of cos theta. So OB is equal to OF. Then we will get this distance, as we have show here that BF, which is denoted by BF, and this distance is equal to apex distance. So we can say that BF is equal to OB minus OF. Here we have said that OB is equal to r secant theta divided by 2, and OF is equal to r. Put the value of these and this equation. So r secant theta divided by 2 minus r. Again take r is common, as we have taken here that apex distance is equal to r into secant theta divided by 2 minus 1. So this is the calculating apex distance. By this formula we can calculate and find the apex distance, and this was the concept of this formula. I hope that you will clear your concept. Now we are going to find tangent length. So now we have taken a back triangle OT2B triangle. As you can see here that the blue line shows the back triangle, as we have written here that and this triangle OT2 is the base of the triangle, and BT2 is equal to the perpendicular of the triangle, and OB is the hypotenuse of the triangle. Now according to geometry, tangent theta is equal to perpendicular divided by base. According to this triangle, here perpendicular is equal to BT2, which is the tangent length. So we have written here that and base is equal to OT2, which is the radius of the curve, and theta is equal to theta divided by 2, which is the whole degree divided by into two parts. Therefore this theta is equal to theta divided by 2, as we have written here that theta is equal to theta divided by 2. So the tangent theta is equal to perpendicular divided by hypotenuse can be write as a tangent theta divided by 2 is equal to bt2 divided by ot2, by putting the value of these p, b and theta. So we are going to find this bt2, which is the bt2, which is the tangent length, and we are going to find this length. So by multiplied radius to tangent theta divided by 2, we will get this, as we have written here that bt2 is equal to r tangent theta divided by 2. So the tangent length is equal to bt2 is equal to r tangent theta divided by 2. This is the formula to find the tangent length or tangent distance. So this was the concept of this formula. I hope that you will clear your concept about this tangent length, and you can find this length very easily. Curve length, the length of arc, which is t1 ft2 is equal to r theta. So length of curve is equal to pi r theta divided by 180 degree in term of radius. Length of curve is equal to 30 theta divided by degree in term of degree in MKS system. Length of curve is equal to 100 theta divided by degree in term of degree in FES system. So at least elements of simple curve, we have got the following elements: angle of intersection plus deflection angle is equal to 180 degree. So or we can also say that intersection plus deflection angle is equal to 180 degree. Intersection angle can be equal that 180 degree minus deflection angle, and deflection angle is equal to 180 degree minus intersection angle. So the tangent length is equal to r tangent theta divided by 2. Central angle is equal to deflection angle. Length of long chord is equal to 2 r sin theta divided by 2. Length of curve is equal to pi r theta divided by 180 degree. Apex distance is equal to bf, which is equal to r into secant theta divided by 2 minus 1. Worst sine distance is equal to ef, which is equal to r into 1 minus cos theta divided by 2. So all these are the elements of curve, and I hope that you will clear your concept about all these elements of curve. So for the calculation of curve and setting out of curve, we will bring a next video lecture. So thank you.